Hey guys, my name's Ryan, totally not a hacker. I am here to present a reverse engineering related, oop, I already snapped my badge. Reverse engineering related presentation that more so covers both the modern spectrum of the reverse engineering space towards education and where things are going from my side of things from a research perspective. So I was here to provide the cyber educational dumpster fire. I call dumpster fire because there is a lot of problems in the space with people that like gouging people for money for courses and people that want to act like experts and sell courses and stuff, and we'll get into that. But a lot of that was what drove this talk, in which case I wanted to bring up a personal case of why the modern space needs to be walked through a little bit more than what it's currently being talked about. So heading straight into it, oh, a small introduction about me. I am a reverse engineer who's been in the space for about five years. I've spent way more time engineering things than I have reverse engineering things, and I totally have not written books in my life. Those are forwarded towards Go, Python, and game hacking. Now, I started my career in game hacking and more so towards the traditional desktop application side, where we were just messing around with x64, x32 traditional ISAs. And I spent a lot of time building kernel mode exploits for things. There's a lot of my space because it bound both computer science and engineering with exploit development. So, of course, now I ended up in Web3 and kind of move over to a few other areas and fluctuate in between. Moving straight into the purpose of this talk, first off, I'd like to shout out a staff member who's not here right now by the name of Hazmat. That's his online tag, who actually inspired me to do a talk on this. And additionally, this talk kind of came up when I was having a conversation about me teaching beginners to try and get into or handle problems in reverse engineering, which has not been a fun ride because a lot of them have been asking me and slandering me with questions from content creators and a whole bunch of other people I get to deal with. So some prime examples of the educational spectrum that I see through beginners would be a lot of the information misleading being one of the first points that I bring up. I bring that point up a lot because I feel like it's easy for people to bring up big YouTube videos and market it well and put out, protect your online privacy and stuff like that, and advertise it out to people in a way that gets them a lot more hooked. So I wanted to kind of drive my insights again from a personal scenario. Covering the cyber educational landscape, we kind of already did. There's already an existing set of stigmas from script kiddies and copy paste code monkeys, but we're not really talking about those people today because those people I don't necessarily see as harmful. While script kiddies can be very toxic people, it's more so the toxicity than it is the script kiddie, and copy paste code monkeys are only harmful in enterprise environments when they are vibe coding thousands of lines of enterprise code. So necessarily because they're not spreading it to other people, they're not telling people this is what you should do, we need to be doing this to throw out products or whatever. So many people focus on that side of things where I feel like we're coming to a part where people want to focus on the side where everybody's trying to copy paste code. We've had the whole AI evolution recently, and everybody's been going on about, oh, copy pasting code is bad, and we're focusing on those sides of things rather than the spectrum of where information's going. So furthering that into why education is more so a target when it's being taught to people is because, one, the clickbaiting, which I had brought up before, and it can get people to view based on popularity. There's a lot of people out there on the marketing side that are really good at marketing, that are very known for marketing, that can make themselves look better than they are in the industry, which can sell people. It's super easy to lead people into being scammed. I've seen way too many people get scammed $4,000 for an hour of consulting, 30 minutes for a coaching call, and programming for $6,000. It's insane. So a lot of my friends too personally have been manipulated this way, and I've seen way too many cases of it. Further issues are more so towards marketing, but a lot of it I feel is just more social engineering. We can kind of group it in a global spectrum. So the main problem here, we have a lot of other areas in the content creation world that spans from course creators to CTF providers, but I'm focusing on content creators. Primary reason why we're focusing on content creators and the reverse engineering relation here is because the reverse engineering space has kind of been this weird moment where only your the face value of major sets of knowledge come from corporations. A lot of your big threat actors, groups that are doing research or end up exploiting something, and then they release a 0-day, and then another company, well, they research that. But we don't see a lot of stuff on YouTube that's very easily accessible to learners, or something that's like surface level, something that somebody not like us would be Googling. Maybe something like, hey, how to reverse engineer, how to get into reverse engineering, or something very surface level along those lines. And there aren't a lot of people that are covering that, and the ones that are have millions of views and take a small crack me and turn it into a really long video about how cracking software is something everybody should do. This is a perfect example. One of the examples I come up frequently when I'm trying to represent, crack me's and the whole spectrum of reverse engineering CTF challenges. This one crack me this person did in a video got really popular, and when he did it, he got a lot of views, and then after his video started popping up, a lot of other people's videos started popping up doing the same thing. And I feel like this is kind of that copy paste repeat rinse wash of content we have, which isn't necessarily a huge problem on the face of people looking at it and being like, oh, I'm just reading this again, but it drowns out a lot of the content that needs to be pushed up and more ranked higher. So just pointing out bigger content creators like that kind of bring it into the spectrum and hide newer areas. Keep in mind the CTF that this guy covered was from like 2006 to 8. I think I could be getting my dates wrong, but it was early to mid 2000s when this crackme was made. So old that it was back when crackmes was crackmes.de and not crackmes.1. So pretty old. Nonetheless, I wanted to kind of round back to a cause and effect of that. So the main cause of people and content creators, more specifically, not really expanding their surfaces, they're not really going out properly into different areas of knowledge, they're fabricating scenarios, or they're taking really simple concepts and they're overcomplicating for them to people, causes a lot of learners to go different directions, which changes the way professionals grow up in the industry. And I feel like when we're coming to this point where we have AI and different forms of access to knowledge literally everywhere, it's hard to limit a lot of that. So what we need to do is kind of move more towards a scenario where instead of trying to solve itself, we try to solve it by teaching beginners discernment and many different forms of mental skill sets that can teach them how to research and verify knowledge. Because as much as that is important on our entire field, and as much as our field relies on research and verifying everything, a lot of people don't do that. There was a few talks I actually had attended throughout the last 2 days that brought a lot of that up too, about how researchers and the way people access knowledge isn't so bright. It's not so creative, and there aren't as many creative people out there as there were, say, 20, 30 years ago when the whole boom of Web 2 happened. So a lot of this transverses into our, traditional, or sorry, not traditional, modern reverse engineering space. When we talk to reverse engineers now, a lot of people that are practicing on CTF crackmes, they're practicing on the same old crackme, same old hard-coded key, dynamic allocation, or sorry, dynamic memory reading and dynamic memory writing, same old concept with key gens, and it's just a constant repeat cycle. So what I've been seeing a little bit more is a little bit more of a use of Electron.js. LLVMs become a very big thing as languages like, languages like Solidity, which are placed on the blockchain, which are built on top of a whole bunch of different layers, start to abstract into. And malware is also kind of starting to port to this weird side where it's using JavaScript to build desktop applications, which is the Electron.js side, which is what we're going to explore, but in a different scenario aside from malware. And it's definitely given us a different angle that needs to be covered, but isn't really covered in the surface level of our education. So I wanted to start off with my personal notice of a shift. My shift was noticed when, over this year at least, I can say a good half of the scenarios I've been working in have at least led to something related to Electron JavaScript. And it's been a pain because I've always been more rounded towards traditional applications, and I've kind of had to understand what exactly Electron is and not get lost in the rabbit hole. But I also noticed that that shift was more prominent in the malware field first, where a lot of people started building crypto drainers out of stuff like Electron.js, and they would look like real desktop apps. So you'd start reversing that were packed into executables. They look like real executables, but then you'd see, oh, this was just a link to an ASTAR file, which Electron.js uses to pack JavaScript code into working executable code. So in that case, you get down a whole rabbit hole of whatever. And additionally, I had some other surfaces and research scenarios that I did that were related to Web 2.0 and Web 3.0 in research that when I was covering or trying to do research coverage and a whole bunch of topic coverage and verification, that there wasn't a lot of people on the surface level that were covering what I was talking about. Even Electron.js, which has gained recent popularity over the few years, there's been talks at DEF CON and Black Hat. There's been a lot of people that just kind of do the same copy paste with it. It's like how to unpack the file. It's how to get past the obfuscation. It's the generic run-of-the-mill JavaScript copy paste stuff. So again, we're here with no coverage. And I wanted to open up with a recent example that was a random desktop app that I used to manage a specific type of manufacturing devices at my house. And this device, I didn't even know was JavaScript. I just quite frankly got interested by a log the script the program had outputted when it crashed. This application of question was filled of many different features. You had your user profiles, projects, cloud projects. You could save projects for offline and online. It cached images and data settings. You could load your own modules, whole bunch of fun things you could do with it. Basically a full-fledged thick client. There were different tiers of subscriptions, and they oftentimes had a subscription service that was constant. So it wasn't like you signed up once. Their tiers were, oh God, I'm trying to think of it, almost like a build where you filled an account instead of just buying the subscription outright. Very, very weird subscription system that got me interested. And it feels like a thin client, though not really. I say feels like a thin client because when you load into the application, it feels like nothing actually happens until you reach the website of things. When it starts reaching out to resources, grabbing images, and loading the cloud infrastructure and the sessions and everything that it needs to depend on. But generally speaking, it's a thick client because it has a lot of serial communication and it has a lot of modules on the client side that make it more so thicker than it does thin. It has no massive requirements on the back end, but it does use a lot of development SDKs and it has a lot of network related dependencies, which is something I realized was a problem. So my first instincts when running this application, when I just was getting curious, was maybe run the application in offline mode. Apps that have offline mode make me curious, and this is something I feel a lot of people don't talk about enough. When modes in apps exist, like offline and online modes, we can take this as, is it completely offline or is it semi-offline in the sense that it's not fully making requests to every resource, or is it splitting it in half? And the reason this is important is because this determines the beginning stage of where we're going to gauge our reverse engineering. In this case of the application, if it was fully online, well, and it was a thin client, not thick, I'd be fully in cloud by the time I even actually start technically reverse engineering the application. But if this is a thin client like it is, then the offline mode probably loads some login screen or maybe some other resources and stuff like that beforehand. Then we're definitely going to see that in the resource dependence when it's loaded upon in online mode. And of course, there's a whole bunch of different things that can change from a single configuration point in an application. It's insane. In this case, offline mode changed the way the project's saved, the way the image is cached, the way the name's cached, the way you can sign in with a username, the way you can load up the application, and everything. Truly insane how much it changed out. So jumping straight into it, finding out what the app actually is, I ran 3 separate tests to run it in offline mode. All three of them had ended up in some form of wacky result. Something led me somewhere. My first test was to just turn off my Wi-Fi manually on my computer, thinking, okay, well, maybe the app's going to manually trigger offline mode. Maybe that's something it detects. Are you already connected to the internet before manually configuring that? And in this case, the app never loaded in. I mean, it loaded up and then it just buffered, kind of just sat there, did nothing. The second app, when logging in and then turning my Wi-Fi off, thinking logging in, getting past that initial network stage and then getting past the preload would help it, that also resulted in the app loading in, but never lets you edit any projects. It lets you navigate and do things, but anything that's outside of the global scope of what a user can do to their profiles locally is changed. Finally, logging in and turning Wi-Fi off manually, that was a separate, not a separate test. I had labeled that twice, so my apologies on that side. But what this was basically saying was there's an extension of it at the very bottom. There's a third box that says edit projects configured as offline. Projects you could configure offline and online in this case, but when logging in and turning Wi-Fi off manually, you still couldn't edit the same projects that were configured for offline, which I found really, really weird. So the offline mode, in conclusion, is pretty much something that's not fully dependent on us having full network connection, but also doesn't need us to have no network connection either. It's still one of those half and half weird options. So this got me to check out the process. What is this application here? So here I have a Procmon process hacker that did not load here because iCloud and PDFs. And I see a bunch of command line flags here. We have, excuse my blur just because I didn't email anybody about this. But when I was doing the research for this and inspecting the process, we can see the app.asar file right here, along with a file that's being rendered as an actual exe. So in this case, this exe that was being rendered was a root process, and all these flags here were actually Chromium-based flags because the process that this was running was essentially packaged and compiled by Electron.js, which will package the Chromium runtime inside of its own environment, which is so wacky and probably why it's really beefy in terms of memory. But anyway, all these flags here are specific to Chromium, and they tell us a lot about the application that's running. The app.asar file we'll get into later, but here I was more specific in that little dot. It's definitely the red is outcoming it, but there is a dot right here followed by a data directory. This is a user data directory that was configured for the Electron application for the application to basically send all its log outputs, any files, any cache, or whatever it was. So given that we have that process, we can actually say, oh, there is a dot directory that is definitely 100% specific to the type of application. The reason we say that is because though I blurred it out, the name of the dot directory was extremely obvious. There were really large amounts of flags that were also indicating that this was an Electron.js application. When looking up user data dir, you see it's apparent with Chromium, and then you see people that use it in final execution steps when executing ASR files compiled by Electron, so the link becomes almost immediate. And the app shows signs of using WebAssembly for its functionality. Now, this is an interesting one because WebAssembly is a part of reverse engineering that's not talked about a lot. And if it is, it's very complicated and it's overcomplicated. I feel like people overcomplicate it because it's one of those new hot things to do. So it's like, oh, if I can reverse engineer this, I'm pretty badass. But the real side of it is WebAssembly becomes quite useless to reverse engineer, but is still on here for us in this case. And I say useless in this case because the WebAssembly that's used here is essentially just to bridge modules on the main system, which when reverse engineering the JavaScript of the ASR file can easily be so much more understood when looking at that versus the WebAssembly. WebAssembly is a topic that I also threw on here for the show aspect of, hey, you know, if we wanted to, we could go here. And a lot of people, my biggest talking point with this was when I look at these videos and people are talking about reverse engineering, they're just doing one thing. There's one objective: get the key, get the flag, get the whatever. And I'm like, that's great, but in real world scenarios, we're going to be 12 hours behind a desk every single day for a week on an engagement, and we're going to go from client to web to whatever pivot we can go to gain some form of control. Because reverse engineering isn't always just about trying to figure out how something works just to figure out how it works, but figure out how it works with an ulterior purpose that ends in some form of advantage. And there's a reason to reverse engineer something. And that reason falls out when a lot of people miss the way things can kind of get intertwined with each other, the way different languages and environments can get intertwined. And as Chrome keeps going up and up and JavaScript and the web keeps transversing the way it is towards Electron, we start seeing a lot more stuff like this pop up. So just a huge highlighting and talking point. So good old Electron. For those who don't know, Electron is just a framework for creating cross-platform Windows, Linux, and Mac apps built using JavaScript. It relies on Chromium, as mentioned, stuffs that fat environment inside of that beautiful 1,000 way too beefy JavaScript file, and allows for WebAssembly integration while using ASAR, or also known as Atom Shell Archive, to package the app's code. ASAR, some people have made it overcomplicated, but if you read their documentation, it literally just states it's essentially an archive file, essentially an archive format. They just made it very performant, and they did a few things to it that made it different for Atom and JavaScript, specifically in code performance. But it's also been gaining a substantial amount of popularity within the last 6 years, as I mentioned in my initial talk. And if you want the full proof for that, they have a download structure of, or download statistics of the last 10 years. Those spikes are very weird. I was kind of suspicious. I was like, why are those spikes going like that? Because they're very consistent, and they're oddly consistent for downloads specifically. But these were just freezing points when apparently something that was going on with the code and development, they had frozen development during these points. So downloads massively dropped when they were trying to push updates. And then this massive spike up here is when Electron in 2022 had their most recent biggest wave of push and updates that changed the entirety of the way Electron works. So this update, and believe it or not, this spike here is around the time I even myself had heard about cases and talks around 2023 and even early to late 2022 at DEF CON start to come out with Electron.js and talking about the fuzzing of it, and with Chromium's new V8 engine and all the other stuff that's going behind JavaScript. So going further into that, just to kind of bouncing back from Electron.js and that talking point, investigating that data dir, the one thing I wanted to look at when I did look at it was the log path. And logs were interesting to me because in this type of application, I saw no reason for logs. Usually in applications, especially engineering applications, logs might be normal. If you're working with like a slicer software like Orca Slicer for a 3D printer, they have log directories. But this app was very consumer and was very proprietary to a point where even an engineer wouldn't be like, yeah, I'm going to be using this. So the log files were something I wanted to check out. And the actions we made at the start and the results of that made me feel like if there was a log here, it was going to tell us. If we were offline and we tried to load it, or it crashed or something we didn't know, it logged it here. And they could hold information to identify internal source code in this case, and other information in the directory is not really relevant to our case scenario, because I'm trying to figure out what this app is doing, not what the user data is, not what the update module is reaching out to, and certainly not what native libraries or modules are being loaded until we reach the actual reverse engineering portion. So logs was it. And of course, the application went boom. So in this case, they had a perf log, assumingly performance log is what that is. It's the only log file, had 5.4 megabytes of log output, all from errors. And it had a very unified and logging custom format that made no sense for any existing logging software to try to parse. So I took a look, and as my scroll wheel doesn't show, I'm all the way up here, but it's very, very tiny because of how big this file is. And immediately we see there's obfuscation to some degree, because JavaScript doesn't always print function names like that. And if it does in a stack trace, it's usually very specific and verbose and configured to do that. This looks like it's coming from an internal program, preferably a compiled program, because wow, that is a lot of columns for a single line of code. So there is definitely a form of obfuscation and compiling that happened here, of course, given it's an ASR file. And of course, we have a message of an error message that happened. So this file already provides a lot for us. It gives us a file path, that it gives us an idea of where things are going, and even gives us the presence that JS is here, which means the initial idea or hypothesis of Electron being there is, well, definitely right here, at least until we verify that it is the ASR file is an actual Electron loaded ASR file. That's a lot of logs. That was way too many logs. I moved my editor an inch across the screen and Windows crashed and blue screened. That was a pain. So I built a logger for it, a log parsing utility in Go. I preferably vibe coded this on the side of a hotel corner at 4 in the morning, because I was very not in the mood to go through that many logs to manually find the stuff I needed for this presentation. Boom automation, and it highlighted a lot of errors that were actually specific to the modules that this was using. Like Canvas, for example, is something that Chromium has. They have engines and plugins for, and Electron specifies APIs for Canvas. So all these errors here were pretty easy to filter, because when we see that there's 273 render views specific Canvas, we can already eliminate those, because We had nothing to do with the canvas when we started and when we were looking at our investigation. Nothing to look at this other than the fact that there might be something in there that could be vulnerable, maybe something crashed, but that it'd be good to put that on the side view now, because that's not the most important errors we want to concern ourselves with, because we're just going to get lost in a bunch of other stuff. So a bunch of other error highlights here and more functions we see, and then we see, oh, well, there's some data here, headers, and that's the kind of stuff we want to pay attention to. When there's logs with JSON data, there's maybe an API request failed and we can replay it and see what's going on. A whole bunch of things here. And of course, I used another filtering utility as an extension of that to take that output and refilter it through JSON and find all the JSON ones, in which case we got fun access to a remote API, which had a app data directory specific to my Windows directory, which was interesting that they defaulted on app data, and app data is a default Windows directory, but it was interesting to see in an API path nonetheless, because I would think that on the back end, they might make that file path and just on a server or whatever's loading it, choose based on system. It was really interesting to see that there, but anyway, it got me more interested to look further, so I did. And this is what we have. So this is where I kind of wanted to make my talking point further on reverse engineering, where people don't say, reverse engineering is only one direct location, because it's not. Here, we're already on their cloud infrastructure. Now, we're on their API, wherever they're hosting their API, we're now on it now. And at this point, maybe we want to start looking at the API and looking at the parameters this is taking and start testing it. But immediately, we already see something that catches our eye. We see the EXCs over here, which are different versions of the application that we can kind of ignore. But we also see the bin files all the way down there. So those bin files, in accordance to what this application was doing, was firmware, proprietary firmware loaded by the IoT device. So now we have a choice of, are we going to go back to the app, or are we going to pivot further and try to find the firmware on Google and Google Scrape and Google Dork and try to do whatever we can to reverse it. From there, you pivot from now client-side reversing to web reversing to now the firmware side. And this is where things start to get a really bit like, maybe it's not just about exploiting their client-side app, but maybe it's about using their client-side app to find something that can help us in exploiting the device. This is where reverse engineering has lost a lot of its weight, because people aren't repeating the way that it can be chained to form a really good exploitation scenario. And that's something that, as much as us threat actors or threat researchers want to use as a talking point, sadly, a lot of the threat research that's out there now is always straightforward. So even in real world scenarios, a lot of people that go more towards reverse engineering, the side that's the most popular is the side with the most case scenarios, which ends up just being one single straight road. Unless in the case you're talking advanced CTI scenarios where you have whole families and then trees, and you're going down a whole different side of reversing. And at that point they showcase it, but then we never get the publicly disclosed part of that, because that's a lot of research to uncover for people, especially publicly. So in this case, I chose go back to the app, because finding that firmware would be a lot. And I already knew that the company that did this does a lot of legal stuff to prevent you from doing stuff to their apps. So if I presented that, I'm pretty sure I might get sued. So saving this for later, going back to the data directory, I went back, the sudden interest in exploring other resources in the data directory is because, one, we saw it was configured as a user directory. We saw error logs, which showed the direct use of that directory inside the log. And there was a side purpose, which gave us to the fact that in the case of this app, we were able to make purchases. We were able to do a whole bunch of things with the subscription service that they had. And one of the subscription parts of it was to have the online shop on the client side. We all know how this goes. Imagine selling a bunch of artwork on a client-side application where the client downloads all the artwork and is like, hey, buy the artwork. Something's going to happen. So in this case, this actually had happened. So we'll pivot into this a little bit more, but building up to this, the first culprit of this was cache. My mind was already racing at this point, because I was like, okay, anything resourceful is definitely here. It's helpful to get the basics covered, because cache can expose a lot now, especially in web applications. We just had a whole thing with the Portswigger. They had released their own flaws with web cache, and that's been a fun thing. And for this type of app, it could be definitely an entry to pirating, which is exactly what I'm going to talk about in a second. So in this case, this cache was what this directory was. Now, These developers like repeating things, and I'm starting to pick that up on their psychology, because this directory had over 3,000 images that were all named the same thing with no extensions in them, or files that were like this that weren't images and looked like images. It's really weird, really weird. But I didn't know what these files were. They had no extension. They were all downloaded relative, so there was no timestamp to say what action did what at what timestamp, so we could coordinate and say, hey, maybe this is a log file versus an image or whatever. And the only thing we have from this is that this is possibly a sequential order in which it was generated. This is an engineer's perspective from my brain of programming, but if we see these numbers here, and when we see the dates coordinated, we think, okay, only 1,000 milliseconds for the program to generate roughly and fill roughly 4,000 files of what was in that directory, all unnamed. They all start with F, so they're all a file. They all increment 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, and then start transforming into hex. And then along those files, data 0, 1, 2, and 3 were all files that coordinated the caches for the network loads that were done through like raw sockets, it seemed. It was very hard to interpret, but those data files held basically the requests that were sent. But instead of sending it through standard HTTP GET, they were building raw sockets to send requests to their APIs. So when the socket failed, you got this random buffer of unprintable Unicode characters that made absolutely no sense, which made those files very, very, very chunky. So I built a, well, I was going to say I built a program, but I haven't even gotten to that slide yet. Before we build a program, we have to analyze and know what the files are. So a lot of these files, when I was opening them up, they had a PNG header, which immediately to me is like, okay, this is images and this is what it's caching, especially considering all of them that were downloaded were in the same, relevant side. So I built a program to sort through and see which ones were PNG and which one weren't. The reason is because though we verified with HXD that one of the images was PNG, even if we had taken a select 5 to 200 out of those 3,000 files and said they were PNG, we still don't know if the few thousand that are left actually are PNG files. So the PowerShell script here makes sure it can read the header of the byte. If it's not PNG, it puts it into a separate folder, or it doesn't put it into a separate folder, but classifies it as different. If it is, then it flags it as a PNG. In that case, this is what it was. So these files had a lot of things in them. There were some of them that were PNGs, GIFs, JSON data, cache data, binary data. There were some things that I saw that were reminiscence of firmware that wasn't full firmware, which didn't make sense to me. But I saw almost headers of binary files, so almost like a API was caching the verification of firmware. And then at the very bottom, there is a RIF header there. So at this point, I'm focusing on the images, right? Because our focus here was, well, if it caches the images on a paid program and it's having you pay for the images, what if we just take the cached images? So building a program for that, even extending it out further, if you guys want to scan the barcode, you can see it on GIST, because that is hard to read. This helped me sort them into files and directories. So everything that it knew was PNG, it would actually rename to a PNG, which was the other monotonous part. Without automating this, I would have to manually rename everything to .png. And even with a bash shell, the script to iterate over it, I'd still end up doing the same thing with bash. So PowerShell, because I was on Windows at the time and I was mobile, just made sense. So that helped me sort it out. And of course, I got this big directory of images. And wow, look at that. They're actual images, and they load. Before in the GUI, I didn't show it on the presentation, but because they had no extension, they weren't identified by Windows. They were just blank files. So definitely still way too many files, and we still need to compensate. So how do we compensate here? My proving point was, maybe given the cache and now we have proof that there's a bunch of images here, maybe we can find an image on the application that we can target that's maybe paid for. And if we find it in the cache, then we can definitely say that maybe everything else is like this. And of course, I'll run my tests after and we can figure it out from there. So we choose a target. On this application, they had artwork for $1. It's crazy. And this resource was paid for with a membership, and you could pay for it through the client-side app. It didn't take much time to render, and when you were offline, it didn't get deleted from the client, which told me on a frame-to-frame update basis, when you think about GUIs updating frame-to-frame and updating their data, if they're not loading from a cache and they're not loading from a local storage, then they're loading from a remote resource constantly. And in this case, when we shut off our Wi-Fi and reloaded the app and the image was still there, in my case, I didn't show this, but the image was still there after the offline mode, I was like, okay, it's probably reading it from cache. In some way, the internal program knows that I don't. So I found it. And there we go. Automating, pirating could never seem so easy. So at this point, because they decided to cache every single photo they download from an authorized endpoint that they thought was smart protecting, we get all the images here. And of course, does that, oh, wow, that actually doesn't show as good. That is the same picture of the sunflowers for those who can't see. And in this case, there were a bunch of other images that I went through that I was able to find that were the same way. In some cases, it only downloaded some of them that were paid and not all of them, but this is probably because of the way that it previews. I noticed that when I was analyzing and debugging HTTP requests, when I was initially starting this research, that the application reaches out to an endpoint to preview the content before it displays it. And when it displays it, it's 100% focused on that page. So if you have a product that's like 50% focused and it's on half of the page, then it would only fully load that content and make that full request once it's done fully loading the body of the content, which even from a development perspective was really weird. So given that we got pirating, we can say we already have something, but I'm interested in more. So I take another look and my God, more files, great, monotony. That's the output I was talking about with those, the socket requests that they were making. And the reason I say socket is because even though I never highlighted it in the presentation, there were a lot of symbols of socket related headers from JavaScript. And they weren't sockets that were constructed by the HTTP library. They were custom sockets with custom options that were being sent to their APIs. So I was like, this is going to be more fun to go to. But of course, it's also going to help us further with our investigation because we see now a public mirror of more images and more resources, even in that one over there. So taking from this doesn't give us too much information, but it at least gives us a grounding point to stop and kind of think, okay, what do we have here? We have an app that acts weird, and we have proof that it's definitely acting weird because that was a lot of logs. And we built a log parser to see if there was anything fun, which there was. And we discussed the decision change, which we chose local. We found out the app caches data and downloads it to the client, which makes it very savable. And we use this as a way to bypass the licensing payments for icon/artworks. And we end up here. So what's exactly next? There's now the side of we can start messing with the client and we can kind of finish our mission, or we can kind of go the other way and go towards web. If we were to choose the client side, we have three main things that already come out right here from the research. And that was the cache abuse was really definitely easy because they were not sanitizing anything. They weren't checking any of the way JSON resources were loaded. When names were changed on the original cache resources, it would load the app and then crash. So it wasn't checking the names, which was even weirder for me to see because even from a development perspective, it makes more sense to check the name before you load the resource to make sure you're loading the right file. But their plugins were also operated the same, and their plugins weren't DLLs where they were like signed and they had all the security configurations, but they were JavaScript plugins that plugged into the application that only went based on a header. That header was stated in the ASR file, and we'll get to that in a second. But the plugins, you could basically just mimic that header and just write your own malicious JavaScript plugin interacting with their processes, which in this case, Electron calls IPC, or inter-process communication, which is where one process communicates with another that it spawns. In this case, you could use IPC with the plugins to do something bad or mess up their internals of their app or expose the security vulnerability. There's a bunch of things that the plugins can release here, but yeah. That being the three things. There's a bunch of other things that we can do with this app, especially following traditional means of reverse engineering, but that was the front facing of it. And now we can actually move on to the psychology of the developers. One thing I like talking to people that I don't think is covered a lot now, and I think should be because it's starting to become a specialty, is learning the psychology of the people that are developing the app. It's hard to take that into terms, but me saying that is a way of saying when you look at the way an application is developed or engineered or designed and the way it works and operates and even functions, there's very, very small things that can teach you about the type of developers you're working with, which can give you inference points on what types or components to look forward to as far as security goes. So in this case, the developers seem to lack storing information properly. This was my thought process when I looked at that log, which is why I kind of got the thought process of maybe we should target images first too, because it was just another backing point to say they're doing things really weird here. And there might be something that they're doing with these images on the client side, because how else am I able to shut my Wi-Fi off and this still keep working unless it just stays in memory? And they weren't, in the case of the way they were doing it, they were looping, and I knew they were looping when I looked at the ASAR file, and I was able to validate this myself and deobfuscate the cluster that JavaScript was, but they had looped their frame. So each frame they were rendering a product, they were rendering it from local storage, and local storage was reloading that storage every 15 to 20 seconds. So that reload was happening when it refetches from that API. So this teaches us about, okay, maybe there's something that they're doing different. Maybe if there's HTTP not being present on every single domain, as there was in some of the log files that I had noticed, some of their APIs didn't have HTTPS on it. Weird for me to see in a world where HTTPS takes 8 seconds to put on a VPS. And the infrastructure that they were using for such an application that basically hosts projects that are images on the internet, it had a really large amount of infrastructure. It had AWS, they had Azure endpoints, they had Cloudflare, they had the CloudFront from AWS, they had buckets, they had everything solely for just images and media resources. There wasn't anything fun like firmware downloads they were storing on their CDNs or anything that was really incredible. It was just the standard run-of-the-mill, oh, we're hosting images here, which really got me wondering about why they made such a complex infrastructure. But we can either infer that A, the developers had money to play with, which in most cases they do, or B, they were uncertain about their infrastructure and didn't know where to maneuver it. Or they got down the pipeline, developed it, and then realized maybe we should go another route and ended up integrating with that existing route that they already had in place. Mainly because of the way everything hops around the side is where I was going from that. So the ASAR file being really simple, as I mentioned in the beginning of my talk, that they're literally just archives. So you can download the ASAR CLI through NPM and run it through NPX, and it unpacks all the files. In this case, I had to block out a bunch of the tabs because it showed the name, but they had a bunch of project workspaces here. And more monotony. 250 project directories. Each file was compiled into not this, I wish it was this. When I looked at it, every single file was clustered in a standard way that obfuscation with JavaScript happens, where it takes that, the separation, all that fun white space that things look nice, and just compresses it into nothing. So like the log file, when I tried to load this file on actually a drive at the time, the not only code editor had decided to crash, but the file decided to never reload in the editor cache, which told me how massive the JavaScript file was. Now, in a modern environment, this tells us two things. One, a developer is not manually hand coding that much lines to where a obfuscator is going to be able to generate that much. Two, it's JavaScript, which gives us a good pointer of, wow, there is a lot of libraries in here. Probably way too many for a desktop app. In which case the obfuscation turns into thousands and thousands of lines of the same code. So I used deobfuscate.io. Funny, because following the psychology, we can just Google obfuscated JavaScript or deobfuscate.js. And one of the first website I clicked detected the JavaScript they used as their own and deobfuscated it. And I was like, oh, so all they did is just go to Google and just copy paste the resulting compile of JavaScript and obfuscate it. Now, I say resulting compile because we are in 2025 and we don't really see a lot of native desktop applications that are written from scratch in JavaScript. It's like hearing the old term of Python versus C++ and native GUI development. It's hard to see a GUI in Python that's native like that works with graphics and is a full library. And when it is, it's usually wrapped in a framework. In this case, they had licenses all stored throughout their directories too, which had showed that they were using a lot of third-party libraries to compile the code. So naturally following this, we can actually go through scripting and we can build a really fun command to go through everything and look for all the URLs here. This is where things get fun. ASAR I love, because even though I have to go through the monotony of the obfuscation, I don't have to do dynamic memory analysis, run tools, run memory forensics, or a whole bunch of things to extract anything. Even if it's obfuscated, the chances of me finding it in the code are very much more likely than that of reverse engineering an application. So it increases the likelihood of getting to an attack surface really, really fast, and a lot more frequently than it does traditional apps. So in this case, we built a small, I say small, command to execute a bash regex, which goes through all of the files in the JavaScript and all the licensing, all the images, even the icons and SVGs, because even some of the SVGs can have resources in them and development resources. So we want to kind of consider everything. Though in this specific command, I was looking for JavaScript because I wanted to map things that were specific to the source code. As at the time of research, I was trying to find points that I could take advantage of in the remote resources that would reflect on the client side, which was kind of my interesting thought process here. And our execution and the way it goes is just purely for API endpoints or any resources like third party they might use. If you guys want to scan, get the logic breakdown, there's a mermaid chart in logic P2 and logic. Those are both separate parts. And then the command QR is the actual GIST QR. So moving from there, the resulting of that scripting was fun. We now have more thousands and thousands of lines of resources. As expected, given the size of the project and given the span of the project, we'd expect this output to be really, really huge. In this case, at the very top, you see that there's a 127.0.0.1 URL, a local host domain. And my thought with that is like, either that's from a standard library or they put that in there and they're a little bit slow when it comes to development and maybe forgot to leave out the localized development server that's running in a production enterprise application. So anyway, that was an important catch, and I just kind of moved on from that because that is a whole nother spiel, and local servers are also something I look for a lot because even though we're in 2025, given the AI spiel, I've also seen a lot of people vibe code applications that have development servers left in the middle of production code, which especially with Electron is common because Electron has a lot of development points. And if you can re-execute the app with certain flags for the Chromium app, then you can enable Dev Console and F12 it and just look at it like it's normal JavaScript in a web app. So this whole file was actually parsed from the JSON output that we got from our results. And in that case, we got all the subdomains for the program. There was a bunch of other things, third-party resources, Stripe, ads, and all the other resources that they were loading from. But the important part from this was also doing this with libraries, right? Like I'd mentioned, we want to not just figure out how to reverse engineer this app, but if we're going to figure out how to reverse it, we need to do it efficiently, especially when you're thinking real world because we're on a time schedule. We don't have 40 minutes to look at a crack me and wonder what the input is doing on input A. So given the time schedule and just thinking theoretically, it would be important to scan libraries because this gives us a good point to start. If we know it's Angular, in this case, which we actually did because the entire plethora of Angular libraries there, we can take it as face value and say the deobfuscated JavaScript is not going to be normal JavaScript that was actually programmed, because we're not just looking at the deobfuscated JavaScript of the development, but the resulting compiled output of TypeScript to JavaScript wrapped around the Angular framework. And that's what we're reversing. We're not just reversing the JavaScript or the Node JavaScript that the developers want. And additionally, we have to filter out through all that. And of course, we can map it. Now, this kind of sucks that this isn't like showing. I kind of expected this just because of the text. I should have had a QR set up. But this is a mermaid chart of blank. And I say on my presentation that it is a full map of every single resource that we found in the JavaScript file. So I wrote a Go program to take the output from the JSON file and formulate it into mermaid charts. And in the mermaid chart, I could focus on what was important. In this little section right here, there is a URL map that says 45 domains, impossible to see, even for me. And then https design.xyz.com. XYZ, insert the name of the app I'm not allowed to talk about, and all these related domains here. All of these domains are specific to the app, and all of these down here are CloudFront domains. And this is the fun thing too, because had I had done dynamic memory analysis, I probably never would have figured out there was a CloudFront domain until I did HTTP sniffing. because the idea of seeing CloudFront in there, especially with the way that they had their resources, they had some of them that weren't actual CloudFront domains and that were just randomized resource identifiers that map to CloudFront domains. And that's where we get into this idea of maybe this is where the JavaScript landscape kind of makes things easier for us, because this entire map on the left side is exactly all 3,000 remote resources that around 3,000 is what that JSON output was. 3,000 resources that this application had used. And this was the smallest scope. And the reason we are scoping it here in this diagram, what this diagram is scoping towards, is Cricket in that application specifically. So the CloudFront here is pretty important for us, because if we're looking at this from a testing perspective, we're like, oh, well, what if they leave some of their CloudFront endpoints unconfigured? Or what are they doing on their APIs with their CloudFront, where they're using CloudFront resources to aid their APIs? And this is where we actually pivot outside of traditional reverse engineering and start touching API reversing and then the web functionality side of reversing. And then we really get into the fun, nifty stuff. They also never had developer docs. So if you looked on Google and thought developer documentation was going to be found, it definitely wasn't. Yeah, a lot of scraping, and a week and a half later of running a Google dorking engine, and I still couldn't find it. Is truly insane how much some companies do go to either prevent developer documentation from getting out there or legally shut everybody up from talking about it. So that is, I sadly did not get to make a conclusion for this presentation because iCloud decided to break on the last minute. But as a conclusion to this presentation, what I wanted to encapsulate here was that there are, as you can see, so many different spectrums of reverse engineering we can go down. If we were to go to YouTube and look up how to reverse engineer, you won't see even Electron JavaScript mentioned until you actually look for Electron JavaScript reversing. And even when you do, the videos are limited. I used a VPN and a few other browsers. I used Mullvad, and then I used some Russian browser and a whole bunch of different other countries, and still couldn't find reversing that was more inherently specific towards educating reversing more than it was either research scenarios on reversing or scenarios where threat actors were applying reverse engineering to malware they were developing. And in which case, that's the good case scenarios that we can learn from, but it's not ideal for somebody who's beginner and surface level who might not understand the technicality that goes behind it. And bridging up to this, I think one of the biggest problems is we have presentations like this which go really, really far deep into the spectrum of where things can get involved in. But one of the conversations I had with somebody I look up to is a reverse engineer guy, was the problem with teaching reverse engineering is not that it's one of those fields that you can just hop into. Web 2.0 is so involved right now and so developed, and even on the side of how much popularity it has socially surrounding it, that it makes things a lot more easier to integrate into, which is why there's a lot more of an overbeef in popularity when it comes to the red team field. Reverse engineering, when you step into it, is very gatekeepy, toxic-y. There's a very large community of people that don't like sharing information, and when you do have good people, they're game cheaters, people that are selling DMAs, or something that's going to get you in some form of trouble as far as career profession-wise. And when you do talk to the small spaces are good, but there's a small amount of subject matter experts that only exist in this field. And everybody that says they are an expert isn't an expert, which is a huge problem with content creators, as we were talking about before. So talks like this can even aid the fact in spreading out that there's so much more to this field. And there's a lot more here that I personally, even as an engineer especially, I'm like, dang, this is like something we should think about, talking about the automation where you apply your scenarios, taking data and building formats and charts to scope where your targets are going to be. Full real world scenarios where this all applies. And with that, that's pretty much the entire talk. And I appreciate you guys taking the time.